During solar eclipses, what we see is that the disk of the moon covers completely the disk of the sun. This fact seems really counterintuitive because the sun is a huge star. It's really gigantic with respect to the size of the Earth or any other planet, while the moon is a pretty small object that let's say revolves around the Earth. We are so lucky, and honestly it's really a matter of luck, that they cover exactly the same part of the sky. So there are times, like in this specific time, where it's exactly at the distance where it covers exactly the sun, and that's we call it a total eclipse. In Boston, we're going to observe about 60% eclipse, and it's something that some people may not even notice from their office window or home. It's going to be the luminosity of the sky is going to kind of change slightly. It's not really such a big deal, but there are going to be many groups of people who will be out there trying to see the slow movement of the moon in front of the sun. When we witness it, we really, human beings feel this almost spiritual sense of feeling, unable to control the sky. Something is happening that they don't control, they don't really know anything about, and everything becomes dark kind of suddenly, because going from 99% of coverage to 100% makes a big difference in the light around us. It's a very short moment, a couple of minutes, where things become very eerie. Animals are very sensitive. At the same time, it's very exciting because now we know, of course, very well what it is. So we know that we're in control. The sun is going to be back. It's not going to disappear forever. So it's a beautiful event. Scientifically, it's actually a great opportunity. First of all, the very simple thing, it allows us to understand the sun better. If you have a very bright object, it's very difficult even for an astronomer to look into it, and definitely to look at the at the border of it, which is a very interesting area of the sun, which we call corona. What the moon does, it helps us covering the bright center of the sun and allowing us to study the corona, which is the outside of the sun. So it was the first time we actually, through a normal total eclipse, we understood that the sun was emitting some flares or something, discovering activity that comes from the surface of the sun. The other thing is that the sun is a very if you're on a massive object, and when we cover it, we are able to see objects that may be behind the sun. And this is why do we see them? The sun should cover the light of these stars or other objects, but that was actually a way for us to understand the bending of the light due to masses, so Einstein relativity. And so it was a way to find out that the gravitational bending of light happens, and this was observed at the beginning of the 20th century in a total eclipse. So people were able to observe a planet that otherwise you wouldn't be able to see because it's behind the sun. Never, ever, ever, and I could say 99 ever, look at the sun directly. People were unknown, even historical facts, to lose their sight because of that. Even a small part of the sun is luminous enough to actually, destroy our retinas.